Hi all, this is Naren. In this presentation, I would provide the solution for question 6 in the concept of stratified covariate balancing taught in HAP 823 at George Mason University. So here's the question we'll be solving. In this question, we have been provided a data set which has the variation and databases in a few counties across the United States. We have been asked to use stratified covariate balancing to report the impact of obesity and access to food sources on diabetes by controlling for other variables. The data is an Excel file. Once you click on the link, it will be downloaded on your system. And in the next step, we shall import this Excel file into RStudio. To import the data into RStudio, I'd use the library read Excel, and then I'd use the read underscore Excel command by providing the path of my file and read it into a table named DB. And then I'd use the command view to look at how the data looks. To perform some data pre-processing, I initially use the call names function and look at the columns in the table. And then I understand that few columns such as geography ID, longitude, latitude are necessary in the analysis. So by using the indexes of the required columns, I drop the unnecessary variables and restrict my table to the required columns. And then again, I use the call names function to ensure that I have the required columns. In the question, we have been asked to describe the data. So I use the summary command and then I look at the overall description. In this, we get the first quartile mean, which is also the second quartile and the third quartile. And also we obtain the values of minimum, median, and max for all the columns in the table. Also, in the question, we have been asked to find out how each and every independent variable is related to the outcome variable. To do this, we have to build a correlation matrix. In R, the package of performance analytics helps us in building a correlation matrix. If you have not installed the package of performance analytics on your system, please use the first command and install it. And if you do have it already, please skip to the second command and just use the library performance analytics. Chart.correlation is a function available in performance analytics package, which helps us to build a correlation matrix. We set the table name, and PCH is a parameter which helps us in plotting the points, and 19 is a value which helps us in plotting it to be a solid black dot. Once the correlation matrix is generated, you can see how the independent variables are related to the dependent variable using the chart, and also you can observe the statistical significance using the p-values. Now we can observe that the population density isn't statistically significant to the diabetes. So in the next step, we can go ahead and drop it. So to get to know the index of population density, I use the call names function and observe that it would be the 6th column. And then in the next step, I would remove the column at index 6 and I would just use call names to ensure that population density is dropped. To perform stratified covariate balancing, we need to have every column in a binary format. So to do this, I binarize each and every column by using their respective means. I use the felse function, compare each and every value in a column to its respective mean, and if it is greater than the specific mean, I set it to 1, else it is a 0. I do this process for all the 13 columns. Now that we have created 13 new columns, we need to restrict the table to these 13 and delete the first 13 columns. To do this, I use the indexes of 14 through 26 and delete the first 13 columns. Then, to send this table as a parameter to the stratify function for performing stratified covariate balancing, we need to transform this table into a matrix format. To do this, I use the data.matrix function. Then, we can calculate the impact of obesity on diabetes by controlling for other variables. To do this, we can perform stratified covariate balancing, and to do this, we have to have the package of stratified balancing. If you do not have the package of stratified balancing installed, you may use the first command, and if you do have it, please skip it and go to the second command and use the library. We use the stratify function available in stratified balancing library and perform the stratified covariate balancing. 2 is the index of obesity, 1 is the index of diabetes, and db is the matrix format. Once we provide these parameters to the stratify function, it performs the stratified covariate balancing and we have the results. We can see that the data is balanced after weighing, and also we see that before performing synthetic matching, the overlap was just 57% and then it became 100%. We also get the p-values and the 95% confidence intervals as an output. We again use the same stratify function to find the impact of access to food sources on diabetes. Just a small change that we would change the number 2 to 10 because 10 is the index of the column which has access to food sources data. We again get the results in the same format as we got in the previous slide. To interpret the results, we use the p-values, and we can say that neither of the models are statistically significant because the p-values are greater than 0.05. And we can also use the charts generated in both the models to see how the data has been weighed by stratified covariate balancing. So with this, I conclude my presentation. I hope you find it helpful. Thank you for your time and feel free to reach out to me with any questions.